Hello everyone, welcome to Study Desk. Today we are going to continue our chapter 1, Real Numbers, class 10 from NCERT. In this video, we are going to solve question number 2 of exercise 1.1. It says, show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. Let's look at the solution. So first of all here, we will take a as a positive integer. Let a be any positive integer. And the divisor b is equals to 6. Now if divisor is equals to 6, what are the possible remainders? So we can say by Euclid division algorithm, a is equals to 6q plus r. For some integer q which is greater than or equals to 0. Here what is q? Q is the quotient. And for b equals to 6, the possible remainders would be r will be equals to either 0, 1, 2, 3, 4 or 5. These are the possible remainders for divisor equals to 6 because r is always greater than or equals to 0 and less than 6 as per Euclid's division lemma. We will consider the first case now. In case 1, you can observe that we can write down a is equals to 6q plus 0. Here r we are considering it as 0. So 6q plus 0 can be written as 6q, which can also be written as twice of 3q. Now we can observe that in first case, we can write down this a value as 2 times of some factor, 2 times of 3q. Therefore, this is definitely even. The reason being a is divisible by 2. Therefore, twice of 3q is actually even value. Now, in the second case, we can observe that we are taking the remainder as 1. So, a will be equals to 6q plus 1. Now, here 6q can be written as twice of 3q plus 1. Now, observe here, we have 2 which is multiplied with some value, let's say k, and we are getting a remainder of 1. So, which basically indicates that this a value 6q plus 1 is not an even number. Otherwise, we would not have got any remainder, right? Since we are getting a remainder of 1, therefore, it is an odd integer because it is not completely divisible by 2. Now, the third case here says that a is equals to 6q plus 2. Here, what are we doing? We are considering r is equals to 2 here. Now, in this case, what can we do? We can take 2 common from both of them and we can write it down as twice of 3q plus 1. So, here we can observe that this a can be written as 2 multiplied by something, right? So, here we are not getting any remainder as such. Therefore, it is an even integer. Now, let's discuss case 4. So, in case 4, what are we doing? We are considering remainder as 3. Therefore, a can be written as 6q plus 3. Now, this 3, we are trying to write it down as 2 plus 1. So, this 6q plus 3 entirely, we are writing it down as 6q plus 2 plus 1. Now, from these two values, 6q plus 2, what are we doing? We are taking 2 common. So, we will obtain twice of 3q plus 1. And this plus 1 will be written afterwards. So, here you can observe that we can write down this entire expression as twice of k plus 1. Which basically indicates that if we will try to divide this entire number with 2, we will get a remainder of 1. Which means this is not completely divisible by 2, right? So, therefore, it is an odd integer. It is an odd integer. Now, let's look at the case 5. In case 5, we can observe that we are taking the remainder as 4. So, we are writing a equals to 6q plus 4. Now in this entire expression, it is easy to take 2 outside as a factor. So we can write it down twice of 3q plus 2. Now this entire number is exactly divisible by 2 because we are not having any remainder as such, right? So therefore it is an even integer. Next comes case 6. So here what are we doing? We are taking the remainder as 5. Therefore a can be written as 6q plus 5. Now this plus 5 we will try to break it down as 4 plus 1. So we will write down 6q plus 4 plus 1. Now from this 6q plus 4 we will take 2 common outside. So that can be written as twice of 3q plus 2. And this plus 1 which is present over here will be written afterwards. So this entire expression can be written as twice of k plus 1. So what did we observe? On dividing this number by 2, we are getting a remainder of 1. Therefore, this number is not completely divisible by 2 and hence it is an odd integer. So we have discussed total 6 cases where we started with r equals to 0, r equals to 1, r equals to 2, r equals to 3, r equals to 4 and r equals to 5. And in all the 6 cases, sometimes we got the integer as an even integer and sometimes we got it as an odd integer. So clearly we can see that 6q plus 1, 6q plus 3 and 6q plus 5, they are of the form twice of k plus 1, where k is an integer. So they are actually not divisible by 2 and hence we can write down any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. Thank you so much for watching.